In last class, I explained even or odd function to apply to the Fourier series. In the Fourier series, I have totally four methods. That first one is Euler's method. In the identification is the given limits are in 0, 2 pi. And second one is change of interval. It is identification. The given limits are not in the form of Euler's are not in the form of even then reckoning all limits are belongs to the change of interval. Next, even or method. First two methods, Euler's method and change of interval method. First two methods, full range methods. In these two methods, we have to calculate N, A, and B. N. Total series we have to calculate. In the last two methods, we have to calculate the half range series. So in the half range, we have to cut in full range in two parts. The first part is N and A. So why do we cut two parts? Because the first two parts, N and A, are cosine function. Cosine is always even function. So N, A, N are combination and B, N is another part. So the full range we have to cut in two parts. One part is combination of cosine function and even function. So totally f of x equal to n by 2 plus sigma n equal to 1 to infinity an some cosine function plus sigma n equal to 1 to infinity bn sine function. So this is totally Fourier series full range. We have to cut at cos an. These two functions are cosine function. So a naught by 2 is a multiple of cos 0. Cos 0 equal to 1. So for example, a naught by 2 has multiple of 1. Taking 1 is a multiple of a naught and replace 1 equal to cos 0. ఒకవేళ మనం సైన్ జీరో తీసుకుంటే ఏమవుతుందంటే ఎన్ బై టూ ఇంటూ సైన్ జీరో ఈక్వల్ టు జీరో ఇంటూ ఎన్ బై టూ కంప్లీట్ గా ఎన్ బై టూ వాల్యూ క్యాన్సిల్. సో దట్స్ వై we assume only cos 0 because cos 0 equal to 1. 1 is a multiple of n by 2. n by 2 no need to change in the multiple of cos 0. Cos 0 the multiply చేయడం వలన n by 2 అనే వాల్యూ ని మారదు. So clearly n by 2 is a cosine function and an is a multiple of cosine function. These two are cosine function. We know that cos of minus theta equal to cos theta. In this way, these two functions are in cosine functions. So that's why we of the full range get n and bn. So n and n is a combination of half range and only bn is a half range of function. So last class we discussed the even or odd function. How to identify the given problem is even or odd. So from the limits, from the given limits are like as minus pi to pi or minus 1 to 1 or minus 2 to 2 like that. Every limit starts from negative to positive. Then we conclude that these method belongs to the given or odd. So next we have to check is given function, is given problem even or odd. So taking f of x, replace x by minus x, we getting f of x, then it is even. Suppose replace x by minus x, we getting minus f of x, the function f of x is odd function. Suppose f of x is even, we have to calculate the first half. The first half means an. In suppose f of x equal to r, then we have to calculate only bn value. So yesterday this topic we have discussed. So today topic is last topic of the Fourier series and last topic of the this year unit half unit. The name is half range series. Half range series is. The half-range series are two types. One is half-range cosine series, and second one is half-range sine series. In the half-range cosine series, we have to calculate the two values a and n. In the half-range sine series, find only b. And issue. So half-range sine. So the identification of the half-range sine series maximum the problem. In this. So the identification of the half-range series maximum problems are statements like as express f of x equal to x as a half-range sine series in the range 0 less than x less than 2. The statement is clearly state that the word as half-range. The half-range word in the given problem. So no need to identification of the problem. So it is clearly mentioned in the question. So identification is clear. So what is the formulas of half-range series? Here, the half-range series formulas are totally changed in the basic formula. So the basic formula f of x equal to a naught by 2 plus sigma n equal to 1 to infinity a n cos n pi x by l, n pi x by l. Here the l is changed to c. So I write the total formula of half-range series. So the half-range series f of x equal to, in the cosine series, a naught by 2 plus sigma n equal to 1 to infinity a n cos n pi x by l we wrote. So here replace l by c. F of x equal to a naught by 2 plus sigma n equal to 1 to infinity cos n pi x by l is the basic formula. Cos n pi x by c is the half range cosine series. This formula is half range cosine series. In the range minus c comma c. So in basic formula, the range comparing with c comma c plus 2l. But in the half range series, we have to compare the given limits to minus c comma c. Next, half range sine series. Half range sine series. It has only one term. The term is only bn. Sigma n equal to 1 to infinity bn sin n pi x by c. Here also the limits minus c comma c. The limits range from c to c. So these are formulas, and we have to write what is n and what is an. So I completed formula for half range cosine series. So the series of f of x equal to a naught by 2, sigma n equal to 1 to infinity a n cos n by x by c, where A is defined as 2 by c integral 0 to c. So why we write 2 by c? Suppose in the even function integral minus c to c f of x dx. For example, each function f of x is even, we have to write to integral 0 to c. That's why actually the basic formula is 1 by L. The basic formula is 1 by L integral c to c plus 2. Here, the limit starting from minus c to c. So, the function in f of x every time is positive. So, if given, that we have to write the limits minus c to c to 0 to c. That's why I multiply 2, but here not L taking c. So, 2 by c integral 0 to c f of x dx is a naught value, and a n equal to 2 by c integral 0 to c f of x cos the multiple of n cos n pi x by c into dx. So n equal to 2 by c integral 0 to c f of x cos n pi x by c into dx. The total display formula is half range cosine series in the range minus c to c, in the range from minus c to c. So this is called the half range cosine series. And next, I'm writing the half range sine series formula. The half range sine series, the half range sine series formula is f of x equal to sigma n equal to 1 to infinity bn sin n by x by c, where bn equal to same formula like that 2 by c integral 0 to c f of x multiple of bn sin n by x by c into dx. Okay, so these two are, one is half range cosine series formula and second one is half range sine series formula. Taking one problem. Suppose the problem like as express f of x equal to x as a half range, I wrote shortcut half range cosine series, half range cosine series in the limit 0 less than x less than 2. In the limit 0 less than x less than 2. So first, we find out the limits. So what is the limits? The limits are 0 to 2. The limits are 0 to 2. So, but we have to define the formula of cosine series minus c comma c. Here, 0 to 2. 0 to 2 is not suitable for half range cosine series and is also not suitable in half range sine series. We have to extend 0 to minus 2. So, in the cosine series, taking minus 2 less than x less than 2. So the cosine series we have to reflect in the Rn. Inside the series we have to reflecting in the axis. The statement is, and the Fourier series of f of x overall the period 0 comes to, it will be changed into minus 2 comes to, contains only sin term givens. The givens are reflecting on the y-axis. So we have to take in the axis, the term is reflecting in the y-axis. The statement is the graph of f of x equal to x in 0, 2 in 0, 2. Let us extend the function f of x in the interval minus 0, 2, shown in the line OB. So, taking a diagram, this one is A, here 2, the origin point 0, and here is minus 2. And this one is y-axis, and this one is x-axis, this is x dash, and minus 2. So, names are, this point is A, L, F, and B. This is the diagram of. So we have to extend 0 to minus 2. So that explanation is the graph of f of x equal to x in 0 to 2. The graph of f of x equal to 0 to, this is the given problem line in the line OA. In the line OA. So OA line 0, 2. Let us extend the function f of x. Let us extend the function f of x in the interval minus 2, 0. So we have to extend the line minus 2, 0. So this is the extension line minus 2, 0. So by the line OB, so OB line we have to extend so that the new function is symmetrically above the y-axis. This line has symmetrical line, the symmetrical line parallel to the y-axis. Therefore, the represents a function minus 2 comes to, that's right. So this function minus 2 comma 2 taking f of x equal to x interval minus 2 comma 2. So in the formula f of x equal to x 0 comma 2, we have to extend the 0 comma 2 to minus 2 comma 2. In this way, in even out function interval minus 2 to 2 f of x dx, suppose is f of x is even, we have to write 2 integral 0 to f of x. That's why we calculating the value of f of x as f of x equal to, the formula is converted to 2 by c integral 0 to c f of x dx. The given limits are 0 comma 2 comparing to the 0 comma c. So c equal to 2. So replace c equal to 2 in the formula. F of x equal to 2 by 2 integral 0 to 2 f of x equal to x. So 2 to cancel. Integral of x equal to x square by 2. This is the x value. Once again, 0 comma 2 is given limits. We have to extend the 0 comma 2 limits as minus 2 comma 2. The explanation of the graph, actually 0 comma 2 is a line. We have to take the symmetrical line minus 2. So this line is 2, this line is minus 2. Why we extend the limit 0 to minus 2? Because the full range is half range. We have to full range convert into half range is only even function only possible. But it is not even because it's starting from 0 and ending from 2. That's why we have to extend the limit minus 2 to 2. ఓకే, ఈవెన్ నాట్ ఫంక్షన్ లో మాత్రమే మనం ఫుల్ రేంజ్ ని హాఫ్ రేంజ్ చేయడానికి పాసిబుల్ అవుతుంది. ఈవెన్ నాట్ ఫంక్షన్ లో మాత్రమే ఫుల్ రేంజ్ ని హాఫ్ రేంజ్ చేయడానికి అవుతుంది. కాబట్టి దిస్ ఫుల్ రేంజ్ ఈస్ 0, 2. సో వీ హ్యావ్ టు ఎక్స్టెండ్ ది -2, 2. ఫుల్ రేంజ్ ఆఫ్ చేయగలిగిన ఏకైక ఏంటంటే in 0, 2 as a -2, 2. So we can extend the 0, 2 to -2, 2. So taking f of x value equal to, my voice in this.
Yes, sir. Investment, sir.
Okay. A naught by 2 plus sigma n equal to 1 to infinity a n cos n pi x by c. Here c is the given limits 0 to 2. So it is extended to -2, 2 from the diagram, comparing the basic limits, general limits of the half range series. So c equal to 2. So replacing c equal to 2 in the above f of x series, the f of x is converted to f of x equal to a naught by 2 plus sigma n equal to 1 to infinity a n cos n pi x by 2. Now we have to find out the value of a naught. So what is the formula of a naught? The a naught formula is 2 by c. A naught formula is 2 by c integral 0 to c f of x dx. So here c equal to 2. Recently simplified 2 by 2 integral 0 to 2 f of x value. So given problem f of x equal to 2. So f of x equal to 2. So replace 2, 2 to cancel, and integral of x, so x square by 2, upper limit replace x by 2, so 2 square 4 by 2 4 minus lower limit 0, so that equal to 0. So finally a naught value for a naught by 2 equal to 2, and we have to calculate it an value. The formula of an equal to 2 by c integral 0 to c f of x cos n pi x by 2, cos n pi x by 2. So replace c equal to 2, we know that c equal to 2 and f of x equal to, so here c into dx, f of x equal to x. Replace c equal to 2 and f of x equal to x in the an. The an is converted, an equal to 2 by 2 integral 0 to 2 f of x equal to x cos n pi x by 2 into dx. So 2 to cancel, an equal to, so we have to apply the integration by parts. The shortcut of the integration by parts, starting from Euler principle, taking x and derivative of x equal to 1. So alternative signs, first one is plus and second one is minus. So x is directly cos n pi x by 2 is not taken directly, applying the integration of cos n pi x by 2. Integral of cos n pi x by 2, it is sin n pi x by 2 divided by n pi by 2. And integral of sin minus cos n pi by 2 n pi x by 2 divided by n square pi square by 4. And simplifying the equation, so in the limits 0 to 2, for example, replacing x by 2, here replacing x by 2, 2 to cancel sin n pi 0, and replacing lower limit sin 0, that is also 0. So totally the term is equal to 0. We have to replace the limits only cosine function. So the cos function minus into minus plus n square pi square by 4, we have to write in the reciprocal 4 by n square pi square, and cos n pi x, that value 2, and minus cos 0, lower limit 0. So here 2 to cancel, 4 by pi n square pi square cos n pi. Suppose n equal to odd number, it equal to minus 1. N equal to even number, it is plus 1. So depends on n. So it is not clearly it is positive or negative. In this case, we have to write cos n pi value is minus 1 power n. Depends on n, is it negative or positive, and cos 0 equal to 1. Suppose taking n equal to odd, n equal to odd, it value, so n equal to 3 minus 1 whole cube, that equal to minus 1 minus 2 into 4 minus 8 by n square pi square. It is n is odd. What about even? Suppose taking n equal to 2 minus 1 whole square, it is plus 1 minus 1, so it is 0. So only n value minus 8 by n square pi square, replacing in the f of x. So the f of x is converted as first to a naught by 2 value. The a naught by 2 value is 2. So 2 plus sigma n equal to only odd numbers. Even numbers are 0, 1, 3, 5 to infinity, and so on. an equal to minus 8 by pi square and n square cos n pi x by 2. So that equal to 2 minus 8 by pi square is constant of sigma. Sigma n equal to 1, 3, 5 to infinity cos 1 by n square into cos n pi x by 2. This is the expansion of f of x equal to x. So in half range cosine series at the limit 0, 2. Every time we have to extend 0, 2 as minus 2, 2. Suppose it is cosine series, it reflecting on y-axis. In sine series, it is reflecting through the origin. And the same problem also calculated in the half range sine series. So the problem statement is like as express f of x equal to x as a half range series in 0 less than x less than 2. So it is not possible to separate total series into two parts. The total series into convert into two parts, it is only possible in the even or odd function. In the even or odd function, the limits starting from -2 to 2 or minus L to L, negative to positive, but the limits are given in the problem 0 to 2. It is not possible to separate the full range into half range series. So that's why we have to extend this 0 to -2. Okay. So 0 to 2 is not possible to separate the full range into half range. It is only possible in the method even or odd. In the even or odd method, the limits are negative to positive. So that's why here 0 we have to extend to -2 to 2. So from diagrammatically, from the diagram, this is 2, this value is organ, taking here a value, this point is L. In the sine function, it is reflecting through the organ. So here -2 this is the so that's why we are extend the limit of 0 to 2 to -2 to 2. Taking the limits are -2 to 2. In the limits -2 to 2, comparing with the general limits minus c comma c. So c equal to 2. Replace c equal to 2 in the function f of x. The f of x formula only bn because the given problem asking in the half range sine series. The half range series sine series contain only bn value. A naught n values are 0. F of x equal to sigma n equal to 1 to infinity bn sin n pi x by c, where bn equal to the formula 2 by c integral 0 to c f of x sin n pi x by c into dx. Replace here c equal to 2 and f of x equal to x. So replacing these two values in bn, this bn is converted into 2 by 2 integral 0 to 2 f of x. So x sin n pi x by 2 into dx. So here also we have to find out the integration by using the integration by parts. In the integration by parts, from the Euler principle, the first preference of algebraic term x, taking algebraic term x, taking algebraic term x 1 and the derivative of 1 is 0, we have to stop at a constant 1. And the next stage, write the signs alternatively. Every sign starting from plus and the second sign is minus. So the work of x is algebraic term work is completed. Then go to trigonometry function. This trigonometry function work is completely opposite to the algebraic term x. So in the algebraic term x is taking directly, in trigonometric term taking not taking directly, and the algebraic term x has applying the derivative, so the trigonometry term applying the integration. Complete opposite work. So taking the integration of sin n pi x by 2, the integral of sin n pi x by 2 is minus cos n pi x by 2. The quotient of x is n pi, it is in the denominator. And the total bracket value integration. First of all, write minus and applying integration of cos. Cos integration sin n pi x by 2 and the quotient of x is n pi. Already n pi by 2 is available. N pi by 2 into n pi by 2. N square pi square by 2 square equal to 4. So the integration process is completed applying the limits 0 to 2. In the 0 to 2, suppose replace x by 2 upper limit in sine function 2 cancel sine n pi. Sine pi, sine 2 pi, sine 3 pi, any angle of pi, it is equal to 0. And lower limit also replacing 0 in x, so sine 0. In the upper limit and lower limit, both values are 0. So I am cancelling the sine function of the above series. And the remaining function are cosine. So I have to replace the limits in cosine. First of all, I am writing the constant terms in the outside. Here minus and n pi by 2 are constants. In reciprocal, n pi by 2 in numerator side 2 by n pi. And the remaining terms are x cos n pi x by 2, replacing upper limit x by 2. So 2 cos n pi 2 by 2. Taking lower limit 0, replacing x by 0, 0 into something. So the total value is 0. Here 2 cancel. So multiplying 2 into minus 2, minus 4 by n pi, and only one value cos n pi. Here n is order cos 2 pi, cos 4 pi, cos 6 pi. Even angles of cos is plus 1. Odd angles of cos is minus 1. But n has odd values and even values are included. That's why we are not conclude that clearly it is not even, it plus or minus. That's why I'm writing minus 1 power n. So the value of Bn is equal to minus 4 by n pi into minus 1 power n. Substituting these Bn into the f of x series. The half range sine series of f of x, the half range sine series f of x equal to sigma n equal to 1 to infinity Bn sine n pi x by c, here c equal to 2. So replace Bn value, recently finding value. So Bn is minus 4 by n pi into minus 1 power n. So sigma n equal to 1 to infinity minus 4 by pi n into minus 1 power n, and multiple of Bn equal to sine n pi x by 2. So write the constant terms in the outside. Minus 4 by pi, it is not possible to extension. So minus 4 by pi is right in outside of sigma. Sigma n equal to 1 to infinity minus 1 power n sine n pi x by 2. This is the a half range sine series in the function f of x equal to x in the interval 0, 2. These problems are half range series example problems. Okay, and I sent PDF, so taking some of the problems as homework. The homework problems are homework is f of x equal to x in the interval 0 less than or equal to x less than or equal to pi. Find out half range cosine series and sine series. Don't find out చేయండి. Half range cosine and sine. Cosine means a naught an value find out చేయాలి, sine means bn value find out చేయాలి. ఇక్కడ c ఈక్వల్ టు ఏమవుతుందంటే పై అవుతుంది. సో అప్పర్ లిమిట్ ఏదైతే ఉంటుందో అదే c ఈక్వల్ టు పై అవుతుంది. We have to extend in half range cosine series as minus pi comma pi, reflecting the value in reflecting the axis symmetrically in y-axis. In sine function also we have to extend 0 to pi as minus pi to pi. It is reflecting to the origin. So statement is just change reflecting symmetrically in y-axis, reflecting through the origin. So remaining all are same. So why 0 to pi is not, we have to write the half range series. It is not possible in 0 to pi. In full range, we have to write half range. It is only possible in even or odd function, not possible in 0 to pi. In even or odd function, the limits are must in negative to positive, like minus pi to pi, minus 2 to 2. That's why we have to extend 0 to pi to minus pi to pi. It has one condition of cosine series. The condition is the reflecting axis is symmetrical in y-axis and a reflecting axis in sine function through the origin. So 0 to pi is not possible to write in half range. Actually, the full range, మా screenshot తీసుకోండి ఇది homework problem. F of x equal to x. Find the half range cosine series and sine series. In cosine series, we have to extend minus pi to pi, reflecting symmetrical in y-axis. In sine function, it is also extended 0 to pi as minus pi to pi to the origin. To the origin. Okay. సో ఇవి టాపిక్ ఇంకా ఇంపార్టెంట్ ప్రాబ్లమ్స్ ఉంటే నెక్స్ట్ క్లాస్లో డిస్కస్ చేద్దాము. హోంవర్క్ స్క్రీన్ షాట్ తీసుకున్నారా? ఏమైనా డౌట్స్ ఉంటే చూడండి. సరే బ్రీఫ్గా మనకున్న మెథడ్స్ ఎక్స్ప్లెయిన్ చేద్దాం. ఫస్ట్ మెథడ్ యూలర్స్. This Euler's method is identification 0 to 2 pi and even or odd. So full ranges రాద్దాం. First two methods are full range. Second method is change of interval. Change of interval. These two methods are even odd. Next, even or odd. It is half range. The even or function limits like as minus 1 to 1, minus pi to pi, minus L to L, minus 2 to 2, like that. So I am not writing the change of interval limits because if Euler's method condition fail and change of even odd interval condition fail, remaining all limits are in change of interval like as 0 to 2, 1, 3. అంటే ఈవెన్ ఆడ్ ఫార్మెట్ లో లేవు అండ్ యూలర్స్ మెథడ్ ఫార్మెట్ లో కూడా మన దగ్గర లిమిట్స్ లేవు. అంటే రిమైనింగ్ ఆల్ లిమిట్స్ ఆర్ బిలాంగ్స్ టు ది చేంజ్ ఆఫ్ ఇంటర్వెల్. సో 0, L. సో దిస్ టైప్ ఆఫ్ లిమిట్స్ ఇన్ చేంజ్ ఆఫ్ ఇంటర్వెల్. ఆ లిమిట్స్ యూలర్స్ అవ్వకూడదు, ఈవెన్ ఆడ్ ఫార్మెట్ లో కూడా లేకుండా ఉంటే రిమైనింగ్ అన్ని లిమిట్స్ మనం దేంట్లో క్యాలిక్యులేట్ చేస్తాం? చేంజ్ ఆఫ్ ఇంటర్వెల్ లో క్యాలిక్యులేట్ చేస్తాం. సో ది ఫస్ట్ టూ మెథడ్స్ ఆర్ వీ హ్యావ్ టు ఫైండ్ అవుట్ ది A0, AN, BN full range wave. So full range wave మొత్తాన్ని find out చేయాలి. In boxed methods we have to find A0, AN, BN. Complete full range equation మొత్తం calculate చేయాలి. In second batch are half range series. The half range series first method is even or odd and today topic half range sine series and cosine series. Half range sine or cosine. For example, the given statement is half range sine series. We have to calculate only Bn value. The given series is cosine series and find the values of A0, An. These two methods only find in the half. So the first half is A0, An and second half is Bn. In the even odd function, we have to check another condition. That condition is replace x by minus x. F of minus x equal to f of x. It is even. So here we have to calculate it A0, An. Suppose f of minus x equal to minus f of x. So it is odd. we have to find only bn value. In minus pi to pi, the function f of x is not even nor odd. In this problem, we have to calculate in Euler's method. ఓకే, మనకు మైనస్ పై టు పై ఇచ్చాడు, ఈవెన్ అవుట్ చెక్ కండిషన్ ఫెయిల్ అయింది. మైనస్ పై టు పై దగ్గర ఈవెన్ అవుట్ కండిషన్ ఫెయిల్ అయినప్పుడు ఆ మెథడ్ని కూడా మనం ఎక్కడ క్యాలిక్యులేట్ చేస్తాము? యూలర్స్ మెథడ్లో క్యాలిక్యులేట్ చేస్తాం. ఇది టోటల్ ప్రాసెస్. ఈ టోటల్ ప్రాసెస్లో మనం హాఫ్ రేంజ్ మీద ఒక ప్రాబ్లం ఇచ్చాను, సెర్చ్ చేసుకోండి. ఇంకా ప్రాబ్లమ్స్, ఇంకా క్లాసెస్ కనుక ఉంటే ఇంకా వీటిలో డిస్కంటిన్యూటీ ఫంక్షన్స్ అవి కూడా ఉన్నాయి, అవి కూడా చెప్తాం. ఓకే, ఆల్ ఆఫ్ యూ రైజ్ యువర్ హ్యాండ్స్. ఇంకేం డౌట్స్ ఉంటే చూద్దాం ఈ లోపల, అటెండెన్స్ తీసుకునే లోపు.
సార్ M1 ఎగ్జామ్ అన్ని డేట్ వైజ్ ఉంటుంది సార్.
ఏంటి
అదే M1 ఎగ్జామ్ హాల్ టికెట్లు ఇస్తారు సార్ మరి.
హాల్ టికెట్స్ ఇస్తారంటావా?
ఇస్తారండి.
మీ వాయిస్ బ్రేక్